Yeah, as you can imagine, they're very very careful people. Those who run nuclear reactors. So that was a very high spec project. It took us a long time to do it, primarily because of all they're very careful kind of ramp up to get to the point where you can go in and fly during an active mission.
Welcome back to Founder Mode,
where we talk to founders doing the wildest stuff and getting their hands dirty.
Yeah, today's topic's robotics that go from the big screen to the biggest hyperscaler builds.
You might think film and construction have nothing in common, but when it comes to precision tools, robotics is actually that unexpected bridge.
Jason, you've worked in like tech and media. Like, what do you think of all the AI video models, like Google's update to VO?
So I watched that keynote from I/O, and I've been seeing all these videos come out. I've started to play with the tool. This stuff is nuts. Like when we're going to talk to Asa in a minute about film sets and robots that are doing the most complicated moves with the camera and amazing stuff. But like when you don't even need the $1 million film set to create something that looks like a blockbuster movie, like when this stuff all converges and you have these films that are part AI created, part, incredible, talented humans doing it, like I think it's a 1+1 = 3 moment. I think it's going to completely change the game, and the creativity and the artistry that can come from it. It's not about people's jobs being destroyed in the entertainment industry. It's about the job changing, which is what we talk about all the time on the show. So like as that example, which I'm talking about, like bringing this creativity that is being ushered in by AI into these new markets like film and entertainment. And we're talking about, using robotics and construction with Asa. How do you think AI, robotics, and all of this comes together across industries, Kevin?
Yeah, it's super interesting. As founders, like part of the goal is to find that new tech. And I mean, honestly, what we've been doing for decades is like thinking about what's the new and exciting things and how do you bring that back to either new businesses or old businesses. And I mean, for this conversation, it actually goes back to the late 90s when Asa and I met, as students at UCLA in engineering. And so I think it's pretty interesting. And I think there's going to be a bunch to unpack here.
Yeah, exactly. And that's what makes Asa Hammond, our guest today, so fascinating. His career connects two things that you would not expect: Hollywood and hard hats.
Yeah, Asa's worked on films like Gravity, built drones to inspect nuclear reactors, had like the sickest climbing wall in his last factory, and maybe if we're lucky, he'll call in from the new factory where they're now working on robotics for construction.
Amazing. I can't wait to meet him. This episode is a deep dive into how you turn tools for storytelling into systems for saving lives, inspecting nuclear reactors, and building the future. Let's get into it with Asa.
Asa, welcome to Founder Mode.
There you go.
How are you? Yeah, from robotics to sort of this Oscar-winning film stuff. I think we've had some just incredible walks and conversations over the years, and now taking this to construction sites. I think it's going to be pretty cool to talk through this with you, and just excited that you're here.
This is a fun one because rewinding. You said this before we started, but like you're always looking forward, right? But let's look back for a second. How did you get into robotics in the first place?
It's kind of like anything, sort of following my interest. My main tenet in life is to not be bored. Generally, just always looking for interest. So following my interest, I started out in Hollywood, working on visual effects, computer graphics in films. So kind of came up in the design world, working on main titles. I worked on a bunch of small things in commercials first, and then kind of moved over into a big titles house called Imaginary Forces. Worked on Spider-Man. That was kind of my big first hard mode thing I did, and I just kept working up in the film world. Had my own company, and then burned out of that. Got sick of doing the creative thing, and really just wanted to work on things that had requirements and specs. And robotics is that. And all the computer graphics, spatial understanding, camera matching, all this kind of really high spec work that we have to do for visual effects, where every single pixel we literally just over and over again loop every single shot, even if it's 13 frames long, and everybody in the whole room is looking at every pixel on the whole screen. They're all perfect, and then it's like final, and you're like, cool, let's go. So you're kind of bringing that mode of attention into the real world, and so now you've got to make sure that you don't hit things, and you're moving perfectly, and all this kind of thing that seems very unrelated, but actually is quite related. And had the opportunity to work with a small group called Autofuss, and they were starting to bring these industrial robot arms into doing motion control and doing commercials. I ended up being the visual effects supervisor on their first big motion control shoot, and then later on when we started ramping up for Gravity, I ended up being the person who took over and yeah, built the whole thing for that show. So it was quite the learning curve. Kind of went home with the stack of manuals for the KUKA robots and read that cover to cover, and came back on Monday and started building stuff. So that was my first real entrance into robotics. Was really just, hey, we need to get this done. Here are the APIs to that robot. So I was like, oh, figure it out. And then ended up in a kind of a more full, longer term dev cycle to produce the tools required to service a big movie like Gravity, with really the strongest visual effects company, the strongest director and DP and actors out there. Definitely, it's a high bar, and so you're really working at a set of tooling that is going to try and be as capable and flexible as possible and as safe as possible to match that effort. Yeah.
So from those early days, like what sticks with you about like building for filmmakers? Like to me, it just seems like this mystical thing. Like I was an extra when I was in LA after UCLA. So Ace and I went to UCLA together. That's where actually we met, 28 years ago, I would say, 27 years ago at this point, and worked on Electric Car Club. So building, an early kind of electric battery powered little racer thing that was just so dope.
Yeah. So it's a very, film sets are kind of, they alternate between being the most boring place and the most exciting place on Earth. And at the time, this is quite a while ago, 2007, something like that. It was very, very challenging. You could not do anything sort of real time in terms of real time adjustment of the camera, which also would have been really unsafe. And so it was specifically built to be kind of on rails, like virtual rails. It's going to do the same thing every single time, no matter what. You've got 4 people on e-stops watching it. We run it at 15%, 25%, 50%. You see, you get it faster and faster. You're first running it with stunt-double for a while, proving this move. And so you sort of ramp up from a safety perspective, and it's always exactly the same move. And so any deviation, and the people release their hands off the e-stops, or they press the button. It's like a dead man switch. In order to kick it back, you now are working in a software called Maya. Maya is a 3D animation software. That's kind of the big heavy lifter for the industry. Has been and still is. It's got easy to use animation tools. So we're sitting there on set. Me or Tarek are sitting there adjusting a few keyframes to just layer in this adjustment, and you push it back out. You're trying to make that loop as fast as possible. You have to pull her out, right? Because you haven't actually run this move. And so to be ultra safe, you're pulling her out. You're then going to run through the whole move half speed, full speed, doing all the same things. Yes, cool. Okay, let's do it. Because she was strapped and basically bolted into kind of an Iron Maiden style thing that she could rotate, and it would tilt her forward. And it would adjust her like this. And then this giant camera arm is like bolted to a massive track racing at her high speed. It's all industrial equipment, so it's all very reliable from a company that's been doing it forever. KUKA, the big industrial arms that we've basically are jamming real-time Linux, be here at this time kind of information. So it's a curve that we're really only adjusting the time parameter on the curve. So whenever we lock in the curve, that curve is safe. We're just making parts of it go slower or faster, essentially. And we even wired it up to like a knob. There's like it'd be like a little like kind of a knob, and there'd be a person, be me, be like slowing down a section of it, and then kind of speeding it up.
So there's that human piece to the robotics element too. It's not just entirely running automated. So Asa, there's things about this that I can imagine are similar as you cross over from industries like film to construction. But like, just take us through the difference between designing robots for films like Gravity and others to like designing construction robots, which is what you're building now, right?
Yeah, sort of. It's all the same concerns, right? Safety, reliability, ruggedness. You always have this user that's like, whenever you're going to introduce something into these industries, and you have people who are already getting work done, they rely on their tools, and those tools have to always work every time. You reach for a hammer. A hammer is a simple tool. It's like it's always got to work. I mean, you can break a hammer, but it takes some malfeasance, and so it's really just trying to make tools. So I feel like I'm a tool maker. I am making the simplest way for people to get the most work done. It's really kind of what it sort of always has been. And the leverage is a whole world of robotics, math, algorithmic that's evolving and improving all the time. And then the other side is whatever mechanical bases that we can rely on that are off the shelf as much as possible. And that just helps you with having it be other problems. Many of the the ruggedness. I mean, these arms are good for 15 years of life. They're just there to weld and bolt stuff, on a factory line forever. So they've been well engineered, and they're a reliable piece of the puzzle. But then you're kind of going in and inserting yourself nowadays at this fully dynamic level. So we've evolved past this very fixed thing that we were doing in the past, and now 250 hertz, we're telling these big arms exactly where to be. So it's more and more on us to design, the safety and smoothness, basically, to make sure that they're not jerking, not using too much energy, that they're not hitting each other, hitting things. So there's a lot of planning that goes into making this be as easy to use as possible. Also, of course, on the UX side, in general, it's got to be safe. Number one, it's got to be reliable. Probably number two, and then ease of use is really the third thing. And if you don't have those things, it's just very hard to get any kind of traction with users. Some people do a lot of robots, and they're all hidden away in a factory, in a manufacturing line, and that's fine. You can get a bunch of nerds, and we can all get around and say, what's the problem? Oh, okay, got to make sure that these little things are flowing into that thing at the highest rate possible. And so you get a team, and they'll build that thing, and eventually they can make one thing, and then they let it go. And there's all kinds of incredible versions of that are out there and made. But it's just kind of a different world when you're out there directly having to work with users. And I am blessed that my father was a general contractor. I grew up summer jobs. I learned how to build things in the shop attached to my house. So construction has been with me from the beginning. Pictures of my dad basically built our entire house in phases. There were times when I didn't have a door. It started out as like a small shack and a big piece of land and like a lean-to carport thing. And then now it's this beautiful, huge kind of multi-building complex. And so anyway, I've been in the construction world and kind of adjacent, watching him. He's finally retired a few years ago, but watching him trying to get technology into his world and just seeing that fail. It's very hard to push technology into the construction world. The only thing that does it is just reliability.
So you sort of like walk through like this precision, reliability, and then this sort of arc between like, kind of growing up in a construction site, going into this cinema sort of movie creative industry, and now back to industrial robots back in the construction site. And so like, which industry would you say like pushes those limits more? Like the limits of like that precision, repeatability, sort of ruggedness? Where are you seeing like the most challenging sort of like, wow, we're really hitting the limits of that? And obviously the technology's probably changed over those 40 years, right? From what's possible, but like from where you sit today, like what's kind of like the limits that you're like working within or really tricky to sort of navigate today?
So it's a really interesting time in the world generally. We have LLMs have really made talking to the sand like possible, which is amazing. And what a great UX unlock. Right? I'm confused on how to do the thing and move Sandra 10 degrees forward. Well, here, let me tell you how to do it, or let me do that for you. You can choose your own adventure and how deeply you want to let the LLMs, control your thing. We're very
Kevin and I have chosen for complete control. The LLMs actually are telling us to breathe in, breathe out right now.
Yeah.
Like everything we're doing is completely,
yeah.
we're
Chat run.
I'm not there
basically
yet. I'm not there yet.
puppet mastered by the AI.
I'll have to get some pointers.
No, don't do it. It may not be right. We may be wrong.
There's this big new thing, right? We can talk to it. So there's a lot of UX flexibility there. So that side of it, but of course we have to work. We're never going to have a thing talking to the internet at runtime. So on sites in all these rugged environments, we have to have a local model, and of course it has to be incredibly reliable. So we think of it as unlocking this sort of flexibility and ease of use at this sort of high level when you're sitting there with an interface that to many people can be complicated because it's got it, you can tumble around a 3D object and you're seeing all this work happening or whatever it is. So being able to talk to it is a big new thing. And then the other thing that's happening in sort of modern robotics is sort of demonstration learning, basically. And some level you can show the sand what you want to happen. And then the sand can at 10 hertz or whatever online while you're doing an action, actually, from a camera stream, from a force torque sensor or whatever, can directly modify the action. So that gets you, the ability to fold laundry. Some people are going after laundry folding or cleaning up a cluttered environment. There are a variety of these tasks that are kind of, or we think of it as a task primitive, that are that require that kind of in the loop modification, and that's now tractable. You can do that in 50 examples, 100 examples, and so you can train a thing that's highly reliable, that gets to our standard of reliability and safety in many fewer examples. So that
I think
levered
it's
into the rest of all the different task primitives that we've been able to do before, moving things around and drilling and whatever.
I like the language task primitives and then your example of folding laundry, because my next question is about how I think the company was called Prenav. You flew drones inside of critical infrastructure. So,
Mhm.
like, I'm just trying to draw some contrast here. Like, some people
Sure.
right now are building robots that fold laundry. Asa, historically, you have done things like teach robots how to fly inside of nuclear reactors, right? So can you tell us a little bit
Sure.
about that and like what those constraints were like?
Yeah, as you can imagine, they're very careful people, those who run nuclear reactors.
Makes sense.
And so that was a very high spec project. It took us a long time to do it, primarily because of all their very careful kind of ramp up to get to the point where you can go in and fly during an active mission. So to the point where you have to go and weigh every single part of your drone, like every single component of the drone. You have to get a full in, all up weight, so that it gets weighed before it goes in and it gets weighed when it comes out. There had better be the exact same mass. The amount of checks, so it's other people. We're also handing it off to operators who are fully suited up when they're going in. So it has to be able to be used with gloves. It has to be inside an environment where we're essentially sort of hardening it to the point where you're sending it into outer space almost. And we just watch the mission through monitors. Um, and I just had a really great team of people who we were working with. We'd been doing a lot of development for a long period of time, and then we got this opportunity. And so, kind of a core group of people kind of just hammered on this problem for maybe a year and a half, something like that, to go through all of the different checks, proving that we could do it inside at our place. And then we go to their training reactor, where they have a full training mock-up, which is the full size thing sitting.
What?
Yeah. And
Full
then
full
Project
scale,
mode.
exact same size, just not a
100%, yeah.
okay.
Yep, because it's kind of
Yeah,
it's on
why
the
not?
reactor that's on its side. And so we're going up and holding a radiation meter at each of the little cores of the wall. Yeah, so then you do it on the full size mock-up, show that it happens, run the full procedure, and then do that enough times.
The movie analogy, the film analogy is like the stunt double. This is the stunt double nuclear reactor.
Yep. Yeah.
Yeah.
This is safe thinking, right? This is
Yeah.
you go through and you do everything many times. This is I understand this is very different from software. Yeah, not quite. Someday maybe, but the industry hasn't gotten there.
I like it. You
Yeah.
talk a lot about the team. I think, and like you said, you had a team of people working together. And I know that,
Yeah.
whenever we talk on our walks, you always talk about like, folks that you've worked with for a long time. And my partner, JJ, and I have worked together now, over
Mhm.
2 decades, and a lot of the same people. I'm curious for you, like, what is it that makes a great robotics team? And like, what are the kind of key roles that you see? And has that changed over the last, 10 years or 15 years? Or is that, today, like you would hire the same sort of key people that you would have hired, in that first sort of like some of those movie runs?
I mean, you learn a lot, obviously, over time. I don't know that I was a great hirer of people. Gravity, I mean, I was the only person for the software, really, software and hardware piece. There was somebody who was working on some of the hardware pieces, so I had to do it all and grapple with it myself. And so I didn't have to really lever other people so much on that project. But then later, as you grow and working on Prenav, for instance, you are definitely have the requirements of all of the different disciplines in engineering, really. And that's the thing that I love about robotics is, from UX all the way down to electrical engineering, mechanical, you're
Yeah.
basically touching all of these different domains, and you need experts in each of those domains, or at least sort of T-shaped people who've got a strong expertise and then can kind of do general things. And in early companies, you really people who are founder types, right? People maybe not willing to go all the way to the point where being founders themselves, but several of the people that we've brought into this new thing are like that. They're self starters. They're going out, and it's somebody that I can rely on. They know a lot about the domain. I can rely on if I hand off a thing, even if it's not directly in their domain, they'll go and just chase it down and give me good feedback, good, clear, direct response. They're not just going to be like, oh yes, sure. You need a conversation that's you need reliable people. You need people who are fluid thinking, and then they have to be, of course, just really, really smart and good at their domain and be willing to work hard.
I do like that Ace and I were both mechanical engineering majors, and he's
Yeah.
actually doing mechanical engineering, where I'm like,
A little bit.
You took the road most traveled, and he took the road less
Well,
traveled.
he finished his degree, and I dropped out and said, I would rather be doing these other things.
Where can folks follow your work? Like, and more importantly, when stealth mode ends, like where can people look it up, and where's the banner going to flip from kind of quiet mode to loud mode?
LinkedIn, X, Twitter. Where's your spot that folks can find you?
I don't do any socials. I have a LinkedIn page, but who cares about that?
I love it.
Perfect.
I love it.
Well, Asa, this conversation was next level. Thanks for helping us bolt together creative tech and hardcore robotics.
Okay, it's great to talk, guys.
That was wild. I don't think we've ever had a guest blend creativity and engineering like that.
Yeah, the way Asa talks about designing robots with both like perfectly designed automations and also the human touch of like the dials and knobs, it reframes the whole conversation.
Yeah, there's this notion of like, he talks about UX and like user experience, the way you're looking at like some beautiful art project or some sort of like incredibly like, choreographed art of, an app on your phone.
Yeah.
And, so a bunch of key takeaways, right? So I think this notion of like Hollywood to hardware, right? How do you go from like, visual effects for Spider-Man, robots for gravity, and then, never really looked back, right? And now it's that creativity meets industrial, where he's taking, the precision of running sort of a special effect over and over now to like robotics, where it's really about how do we do it safe and how do we do it repeatable, and then very, very simple, right? Because that's, non-negotiable in construction, right? You need to be able to have a tool that you can use.
For like 15 years.
Just being this tool maker at heart, right? Robotics has never seen the better tools, but again, how do you make them rugged, reliable, and intuitive? And I remember back when we were building projects as engineering students at UCLA, stuff would break all the time. It felt like we were in the shop repairing it. And so I think a lot of what they've worked on is really how do you, complete that repeatability for a place where people aren't probably taking care of some of those tools. Drones in the danger zones. I mean, the story of flying in the nuclear reactor and, having to weigh every part and really understand that whatever went into the reactor also came out, which is a pretty critical thing.
And a full-size stunt-double nuclear reactor.
Right. Wild. Like the fact that they were practicing, but again, kind of practice makes perfect, and perfect practice is what really brings it home. And so, but seeing the future is kind of this software, right? Betting on AI, but then also, using that real-time learning and these software defined robots to actually sort of know what you're expecting, step by step, but also sort of realizing that, the humanoid walking around in our house or with our kids or pets is probably not coming anywhere soon.
That's probably for the best. All right. So if you're building in robotics, or you just love where this like concept of tech meets creativity, send this episode to your friend, your founder, somebody that's building something just like
and
this.
And subscribe if you haven't. Lots more stories like Asa coming your way. Super interesting builders and founders coming in the next couple of weeks. And obviously your reviews help us get the story out to more people.
Yeah, all the links from today's episode will be in the show notes. And next week, we're going to talk about the intersection of AI and the enterprise. So how do big companies adopt or not adopt AI? And how can you apply that founder mode mindset, even if you're inside of a big, slow-moving organization?
That's a wrap. Because great engineering, like great filmmaking, is all about precision under pressure.